So page 2 of properties of circles. We're going to start looking at some of the sections of the circle. Just point out some words here. A central angle, it's an angle made by two radius. Okay, so in the diagram given there, the two radius are obviously the red lines. Okay, the angle between them would be our central angle, we'll call that theta. The area that's formed there would be called a sector. It's always the part that's enclosed by two radius. Okay, and the other kind of area you could have would be a segment. Okay, it's formed by an arc, that would be the rounded part on the outside, and a chord, a line that does not go through the center, and the space in between, we call that a segment of a circle. If we want to find things out about these portions of a circle, one of the things we can find would be an arc length. It would be kind of helpful. Okay. Thinking about a circle, the distance around the outside of it, that's our circumference, has a formula 2 pi r. If I want part of that, let's say I want from here to here, that the distance here would be called my arc. Well, that's a portion of the entire 360 degrees, right? So to figure that out, I can talk about the central angle, the angle between these two things, and if I knew what angle that was, I could figure out the arc length by taking a portion of my circumference. The formula we're going to be working with would be this one right here. Okay, so your central angle divided by 360 will give you your portion of the circle, and then you want a portion of the overall circumference, so we'll use 2 pi r. We can rearrange that equation if you would. Just take all the parts and pieces on the top and multiply them together and put it out of 360. And we can work through that equation, solve for a, or if you want to, solve for r. Taking a look at the first example here, I want to find the arc length. So using that equation, a equals 2 pi r theta out of 360. I can find my arc length using the radius of my circle and the central angle. So 2 pi times r is 10.2. My angle, my central angle between the two radius is 200 out of my 360 degrees. Will give us an answer of 35.6 centimeters. In part B here, you guys can give it a try. Pause the video if you want to, or keep watching if you're not quite sure yet. We're using the same equation, so 2 pi r theta out of 360. In this case, the radius will be 4, the angle would be 40, and we still have the 360 in the bottom. On our calculator, and we'll end up with 2.79 centimeters for the second one. Let's try the third one here. I'm just going to drag it down to the bottom. And the third one here, we're looking for something different this time. Finding the radius when we know the arc length. To do this one, we can still use the same equation. The equation's not going to change. We're just going to solve it slightly differently. Right? Here we know the arc length. That's 215. 2 is 2, pi is pi. I don't know the r, so we'll leave the r there. But I do know that the angle is 260 degrees, so times 260. The nice thing about this is, when we multiply things together, the order we multiply in doesn't really matter. So I can multiply the 2, the pi, and the 260 all together, and have the r attached to it. And so 2 times pi times 360 times, 260 divided by 360 is the same thing as saying 2 pi r times 260. Well, now I can do the math part. I can figure out what this is. And I know it's going to have an r attached to it at the end, so I end up with 4.54 with an r attached to it. If I want to find the r, the radius, I can divide out the 4.54 from the left and the 4.54 from the right, and I can find out that the radius is actually 47.38 centimeters. And that's about all I can really do with arc length and radius.